Hello guys, welcome to another video on probability distribution. In today's video, our main focus will be on binomial distribution. So what is a binomial distribution? A binomial distribution is a probability distribution used to calculate the likelihood of a specific number of successes in a fixed number of independent trials, where each trial results in either a success or a failure. So the binomial distribution is normally performed using a process called the Bernoulli process. Yeah, and it results or the result gives two outcomes, either a success or a failure. And let's look at some of the conditions that must be necessary or that qualifies for you to use the binomial distribution formula in a given scenario. So the first one is we have a fixed number of trials. That's your n is fixed. Then only two outcomes per trial, either a success or a failure. Then the probability of success, that's a p, is constant. Also, we have independent trials, meaning that one trial doesn't affect the other. So if you have all these four conditions, then or if all these four conditions are true, then you can use or you can apply the binomial formula, for which I'm going to introduce it very soon. Also, it's very important that we understand and know some of the key characteristics of a binomial distribution. The first one is a discrete distribution. That's a random variable can take only whole numbers, as from 0, 1, 2, and that order, as I described in the previous video. Then we have a fixed number of trials. Your n is fixed. Also, two outcomes. That's the probability of success given by p, and the probability of failure is given by 1 minus p. In other words, consider the probability of success is p and the probability of failure is what q, where your q is basically 1 minus the probability of what success. We also have what constant probability, meaning that the probability of success is the same throughout all the trials, and the outcome of one trial doesn't affect the outcome of the other. That's what we mean by saying that the trials are independent. The trials are independent. And now, what is the shape of the distribution? So the shape of the distribution, depending on p, that's the probability of success. So if it is we are having p to be 0.5, then we are having a symmetrical distribution. But if p is less than 0.5, it is skewed to the right. And if p is greater than 0.5, it is skewed to the left. Also, one thing you need to note under the binomial distributions are these ones. So under the binomial distribution, to find the mean is given by that's the fixed number of trials, that's your n, multiplied by the probability of success. And to find the variance, also given by npq, where your q is what, your 1 minus p. And basically the standard deviation is the square root of the variance. And the variance is given by npq. Now, what is the formula for binomial distribution? So, we want to find a specific occurrence, a specific number of what success we want to find. It is given by n combination x multiplied by probability of success, we raise it to the power x 1 minus P. That's the probability of failure. N minus X. In another way, you can write the formula as N combination X P to the power X. Then everything here is Q to the power N minus X. Where your N, the formula is the number of trials, and the binomial, I told you that the number of trials are fixed. Then X is a specific number of successes you would like to find, and your P is the probability of success, and Q, which is your probability of failure. Also note that in binomial distribution, the variance we have here, the variance is always less than or equal to the mean. The variance is always less than or equal to the mean. But there are exceptions. The only time the variance will be greater than the mean is when the probability of success is greater than 1 or is equal to 0. When the probability of, so let's take for instance, we have probability of success, that's P, to be 0.2, and you have your N to be 10. How do you find the mean? The mean is given by N, that's 10 times 0.2. Which is giving us 2. Now let's find the variance. The variance is given by N times N is 10, then our P, that's probability of success, is 0.2, and Q, that's probability of failure, is 1 minus the probability of success, which is 0.2, giving us 0.8. So now you're going to have 10 times 0.2 times 0.8, which is giving us 1.6. So what I mean here is always in binomial distribution, the variance is always less than or equal to the mean. But there are exceptions. The only exception is that when we have the probability of success being 1 or 0, then we can have the variance greater than what? Being greater than the mean. So let's take note of that one too. Also, the binomial distribution can be approximated to what? A normal distribution. The binomial distribution can be approximated to a normal distribution under the following condition. That's if N is large, that's the number of trial is large. How large? It should be greater than or equal to 30. Then your NP, that's your mean, or the number of trials times the probability of success, or the number of trials times the probability of failure should be greater than or equal to 5. Then the binomial, you see that the binomial distribution approximates to what? A normal distribution. Now let's take an illustration. A salesman makes a sale on average to 40% of the customers he contacts. If 4 customers are contacted today, what is the probability that he makes sales to exactly 2 of the customers? Now let's identify our variable here. So a salesman is able to make a sale on average 40%. So now let's say that anytime the salesman contacts the customer, there's a probability that, or there's a 40% chance that it is going to make a sale. So that's the probability of what? Success. That's our P, which is 40%. That's 40 over 100, giving us 0.4. Then what's our Q? That's probability that he will not be able to make a sale when you contact a customer is 1 minus P, 0.4, giving us 0.6. Also, they've given us a fixed number of trials here, as in a fixed number, that's our N. They've given us 4 customers for today. So our N is 4. Now we are being asked to find probability that is able to contact exactly 2 customers. Is able to contact exactly 2 customers. So now it's given by, we know that for binomial, we have to find this. We don't know the probability. We know that another binomial, someone is given by n combination x. And it was success over x minus x. Probability that x is equal to 2 is given by our n, which is 4 combination 2, 0.4 x, which is 2, and then 0.6 n is 4 minus 2. So we have 4 combination 2, 0.4, 0.6, or 2. Now 4 combination 2. 4 combination 2 is 6 multiplied by 0.4 to the power 2, which is given 0.16 times 0.6 to the power 2. It's also giving us 0.36. And the final answer becomes 0.3456. You can say that the probability that it makes a sale to exactly 2 customers is 0.3456, or as I said, 34.56%. Good. Now let's solve another illustration. A brokerage survey reports that 30% of individual investors have used a discount broker. So who is a discount broker? A discount broker is one who does not charge full commission. In a random sample of 9 individuals, what is the probability that exactly 2 of the sampled individuals have used a discount broker? Not more than 3 have used a discount broker, and at least 3 of them have used a discount broker. So kindly pause the video and identify the variables in it. Are you able to identify N, your P, and your Q? So pause the video and identify them. Alright, so now let's dive into the question. So we have a brokerage survey. I report that 30% of the individuals have used a discount broker. So this becomes our probability of success. That's a P. So 30%. So 30%, that's 30 over 100, which is 0.3. That's the probability of success. Now, what about the probability that they are not going to use a discount broker? It's 1 minus your P, which is 1 minus 0.3, 0.7. Okay, now we have a sample of 9 individuals. So which is our N? 9. Now we have to find, now we've identified all our variables. We have the phase number of successes, 0.3, that of the failure, 0.9, and n, which is at 9. The A is saying that let's find the probability that exactly 2 of the individual samples have used a discount broker. So exactly 2. It will have n, which is 9 combination 2, multiplied by 0.3 equal to 0.7, 9 minus 2. 9 combination 2, 0.3, 0.7, 7. So 9 combination 2 is giving us 36. And please take note that for combination, then we have n combination r is given by n factorial divided by n minus r factorial r factorial. What does it mean by factorial? So assuming I have 4 factorial, it's given by 4 times 3 times 2 times 1. So as I go, I reduce it by 1. It decreases by 1. So this one, for instance, that's 9 combination 2. So 9 combination 2 is going to give me 9 factorial divided by 9 minus 2 factorial 2 factorial. And later we are going to have 9 factorial divided by 7 factorial times 2 factorial. Nine times 8 times 7 factorial divided by 7 factorial times 2 times 1. So we can basically say that this will cancel this. Then this 2 can cancel this 4 times. Now we are getting 9 times 4, which is giving us the 36 we have over there. Can equally use the calculator to solve for n combination 2. So now 0.3 squared is giving us times 0.09 times 0.7 squared, which is also 0.49. 36 times 0.09 times 0.49. So sorry. 0.7 over 7 is also giving us 0.082. We have 36 times 0.09 times 0.082, which is 0.26568. 0.26568. Let's come to the B part. Not more than 3 have used a discount broker. Not more than 3. If you're saying that out of the 9, not more than 3, it could be 3 or what, less than 3. So probability of not more than 3 is given by probability that none is going to use the discount broker probability that 1 is going to use, probability that 2, and lastly probability that 3 is going to use. So in this case, let me try to explain one or two things here. So we have at least, at most, then less than, so have greater than. So at least is greater than or equal to. Assuming this this example, you have to find probability that at least or more than equal to 3. So they mean that 3 is what? Inclusive. We are going to start from 3 going. But if more than 3, as in talking about the greater than, as it will move to the greater sign. More than 3 of the investors will invest with a discount broker, then this scenario like this, I'll start from 4, 5, 6, 7, 8, 9. That's what. Let's take note. And also at most deals with less than or equal to, less than or equal to, less than or equal to. Now let's find probability that none of them with the positive added to the probability of 1, 2, and 3. So it's given by 9 combination 0. Then probability that they will deposit is 0.3 to the power 0, 0.7. You have n minus your x, so here is 9 minus 0. It's giving us 9 plus 9 combination 1. We are here 0.3 power 0.7. 9 minus 1, which is giving us 8, plus 9 combination 2, 0.3, 0.7. So we have 9 minus 2 giving us 7. Then we do the last one, 9 combination 3, 0.3, 0.7. 9 minus 3 giving us 6. So now let's find each one of them. Let's find each one of them. We have 9 combination 0 times 0.3 plus 0, which is giving us 1, 0.7, 9. So the first one, we are having 0.041, 0.040, 0.040. And the second one, we have 9 combination 1 times 0.3 to the power 1 times 0.7 raised to the power 8 plus 0.15 plus 9 combination 2 times 0.3 squared times 0.7 also raised to the power 7, 0.267. Then we have the last one, 9 combination 3 times 0.3 to the power 3 raised to the power 3 times 0.7 raised to the power 6, 0.2 6, 7. 0.267. Now let's add everything. 0.040 plus 0.156 plus 0.267 plus 0.267. So we have 0.73. 0.73. Okay, let's take the last one. Find what is the probability that at least 3 of them have used a discount broker. At least 3 of them have used a discount broker. Now we have our first number of trials to be 9. And here you have to find the probability that at least 3 of them are going to use a discount broker. And you know that you have 9. So if at least mean that is 3, probability of 4, in that order up to probability of 9. You can do that manually, one after the other, but it's tedious. So how do we rewrite the probability of at least 3? So probability of at least 3 can be written as 1 minus probability of x less than 3. So now you have to find probability of less than what? 3. Probability of less than 3. And we know that probability of less than 3 is given by probability of 0 plus probability of 1 and probability of 2. So I'm not going to solve this one. I'm just going to pick the values here because I have them here, which is 0.040 and 0.156, which is giving me 0.196. 0.196. And there are 2, then I'll also pick this one too, plus 0.267, giving me 0.463. 0.463. Now we found here, how do you find at least 3 of them use a discount broker? At least 3 of them use a discount broker. So now at least 3 of them use a discount broker will be equal to 1 minus 0.463, which is 0.537. 0.537. Now let's solve the last question. So if this, let's solve this. A multiple choice test contains 8 questions. With 3 answers to each question, of which only one is correct. A student answers each question by rolling a balanced dice and checking the first answer if he gets 1 or 2, the second if he gets 3 or 4, and the third answer if he gets 5 or 6. To get a distinction, the student must secure at least 75% correct answers. If there is no negative marking, what is the probability that the student secures a distinction? So what is the probability that a student secure at least 75%? That's to get a distinction. You have to secure at least 75% correct answer. Now let's identify our variables. So n is 8. Then probability of success. Probability of success, meaning that out of the 8 questions, you have one option being what? Correct. And these options are 3. So probability of getting the answer correct out of the 3 options is 1 over 3. And probability of not getting is 1 minus 1 over 3, which is 2 over 3. Now, the question is asking us that what is the probability that a student secures a distinction? A student secures a distinction. And to get distinction, out of the 8 questions, you must at least get what? 75% correct. You must get 75% of the questions correct. Good. So now we have a total number of what? 8 questions. And now to secure a distinction, we are saying that if you have 75%, at least 75% of the questions correct, of the total questions. So now 75% times 8 is giving us what? 6. Meaning that to secure a distinction, you must get at least 6 or more of the question to secure a distinction. To secure a distinction. So now we are finding probability that x is greater than or equal to 6, which is probability of 6 plus probability of 7 and probability of 8. So you must score at least 6 or 7 or what? 8 question to secure a distinction. Alright, let's do the first one. So you have 8 combination 6. Probability of scoring is 1 over 3 or 6. Then 2 over 3 n minus x, which is 8 minus 6 given us 2, plus 8 combination 7, 1 over 3 or 7, 2 over 3, 8 minus 7, which is 1, plus 8 combination 8, 1 over 3 or 8, and 2 over 3. 8 minus 8 is giving us 0. So we have 8 combination 6 times 1 over 3 raised to the power 6, 2 over 3 squared, 0.017. 0.017. Then 8 combination 7 times 1 over 3 also have 2 over 3 times 2 over 3, also raised to the power 1. Giving us 0.002. Then the last one, 8 combination 8, 1 over 3 to the power 8 times 1. So in number raised to the power 0 is 1. Also giving us 0.0015241. So you add everything, 0.017 plus 0.002. It is giving us 0.01915. So these two, the decimals, so we're getting something around this area.